Hello Math 1 class, this is Mr. Liao and we're on section 11.2 reflections. This is going to be part 1 of 2. So the objective in part 1 is just to perform reflections. We'll look at the other 3 objectives in part 2. Alright, a reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called a line of reflection. So what a reflection essentially is if you were to fold a sheet of paper on that line of reflection, so in this case line M, it would overlap itself perfectly. That's what a reflection is. So whether it's a line, a point, a shape, a triangle, whatever, if you were to fold something on that line where you would fold it over that line, it would overlap itself perfectly. So a reflection in a line M maps every point P in the plane to a point P prime, so that for each point the following is true. If P is not on M, like in the first example here, then M is the perpendicular bisector of P prime. So notice that if you were to fold across line M, P and P prime would overlap themselves. They are the same distance away from line M. If P is on line M, then the reflected point is actually on the line itself. So if you were on the line, it would just be on the line itself. So again, that means that point P is the same distance from the line of reflection as P prime. So if you were to do this on a coordinate plane, all you need to do is count how many boxes or how many units away a point is from the line. And then you would basically go in the opposite direction, the same distance away. So if you were to start at point P here, for example, and let's say this were 3 units, you would start at the point where P intersects line M and you would go the opposite direction, that same 3 units. So point P prime is going to be the exact same distance from the line as point P in the opposite direction. Now again, if a point is already on the line reflection like point P in the graph on the right, then the new point is also on the same line. It doesn't move. Sample 1A, graph the triangle with vertices A1, 3, B5, 2, and C2, 1, and its image after the reflection described. So we're going to reflect across the line x equals 3. So the first thing you want to do is graph the triangle. So A is at 1, 3, B is at 5, 2, C is at 2, 1. We have a triangle. That's the pre-image. Now we're going to graph the line of reflection x equals 3. So it's that vertical green line. Now to do this, we're going to figure out how far each vertex on the triangle is from the line of reflection, the green line. So let's start with point A. You will notice that point A is 2 units to the left of the green line. So A prime has to be 2 units to the right of the green line. Same distance away from the green line, but in the opposite direction. So that's where A prime is. We're going to repeat the same process for points B and C. So B is 2 units to the right of the green line, so B prime has to be 2 units to the left. C is 1 unit to the left of the green line, so C prime has to be 1 unit to the right. Now we're going to connect the dots together, and that is our reflected triangle. Now if we were to fold along the green line, you will notice that the red and the blue triangles would overlap themselves perfectly. That's the idea of a reflection. When you fold across the line of reflection, the shapes would overlap. Now we're going to do 1B, or you can do 1B, same triangle, but now we're going to reflect in the line y equals 1. So let's start by graphing the line of reflection y equals 1. That's a horizontal line through 0, 1. So again, we're going to count how far each vertex on the triangle is from the line of reflection and place new points on the opposite side the same distance away. So A is 2 units above the green line, so A prime has to be 2 units below. B is 1 unit above the green line, so B prime has to be 1 unit below. Now notice that C is actually on the line of reflection, and if you remember the previous rule, if a point is on the line of reflection, the image or the after image is also at the same point. Okay, so C and C prime are on the same spot, both on the line of reflection. Now we'll connect the dots together, and you can see this triangle is a reflection of the blue triangle, the red one. So if you were to fold the triangle across the green line, you would get the blue triangle and the red triangle overlapping themselves perfectly. All right, now we're going to do the same thing, but now we're going to use a different line. We're going to use the line y equals x, and we're going to use a segment. So f is at -1, 2, g is at 1, 2. So those are the two endpoints of the segment. Now we are going to graph the line y equals x. So that's the green line going left to right with a slope of 1. So what is the slope of y equals x? Well, as I mentioned, it is 1. So if you remember from chapter 10, the distance from a point to a line is the length of the perpendicular segment from the point to the line. So the perpendicular slope is -1. So what we're going to do is draw a line with a slope of -1 from both points F and G to the line of reflection. So those are those little black segments. So now we're going to go in the opposite direction from the green line, the same distance to plot points F prime and G prime. So notice F prime is 1.5 diagonals away from the green line. If you start at F and go to the green line, it's about 1.5 diagonals away, which means F prime has to be 1.5 diagonals away from the green line, but in the opposite direction, right there at 2, -1. G prime is half a diagonal away from the green line, so G prime has to be half a diagonal away in the other direction. Now we can connect the segments together, and that represents the reflected segment across the line y equals x. Now notice there's something happening with the coordinates. F's original coordinates were -1, 2. F prime is 2, -1. All we've done was flip-flop the x and the y coordinates. G's original coordinates were 1, 2. G prime's coordinates are 2, 1. Again, flip-flopping the x and y coordinate. So this leads us to some rules for reflections. So here are the rules for reflections. Let's start by reflection across the x-axis. If the original point is a, b, then the new point is a, -b. So let's suppose our point was 3, 2. Under the first rule, this would become 3, -2. Because you would keep the same x coordinate, but you flip the sign of the y coordinate. Next, if a, b was reflected in the y-axis, then its image is the point -a, b. So in other words, the x coordinate gets its sign flipped, but the y coordinate remains the same. So if we start at 3, 2, the new point would be at -3, 2. The third rule, if a, b is reflected in the line y equals x, then its image is the point b, a. So we just saw this in example 2. You would reverse the x and y coordinates. So this would be, say, 2, 3. Finally, if a, b is reflected in the line y equals -x, then its image is -b, a. So you're going to flip the coordinates and change both of their signs. So this would become, say, -2, -3. Okay? So this year, because of our shelter in place, you're going to have access to your notes or the textbook when you take the quiz. So if you forget all these rules, you can look them up as we take quizzes and tests. So for each example in example 3, you're going to start with a segment and we're going to apply the rules. Now, if you forget the rules, you could always graph the line of reflection and do what we did in example 1. Take each endpoint, see how far it is away from the line of reflection, and then go that same distance in the opposite direction. But in this example, we're going to apply the rules. So we have FG, which is at -1, 2 for F and 1, 2 for G. And we're going to graph the line y equals -x, which is this downward sloping line. We're going to apply the coordinate rule for reflecting in y equals -x. So the rule is a, b becomes -b, -a. So you remember from 11.1, you have this arrow that is basically a transformation rule. It tells you what to do with the original coordinates and what to do to get the new coordinates. So for a, b to -b, -a, you're going to flip the signs for each one and then switch their position. So -1, 2 for point F becomes -2, 1. So you flip the coordinates, which becomes 2, -1, and then you change each of their signs to -2, 1. So there's -2, 1. For G, 1, 2 becomes G prime, which has -2, -1. Now I've noticed that F and F prime are the same distance away from the green line. G and G prime are the same distances away from the green line. So even if you don't remember the rules, you can apply the rule about how far the points are from the green line and going the same distance in the opposite direction. Example 3b, graph AB with the endpoint shown and its image after reflection in the line y equals x. So let's graph segment AB and the line y equals x. And again, if you don't remember the rule, you can look it up. So the rule is A comma B becomes B comma A. All you're doing is reversing the X and the Y coordinates to get the new one. So A was 3, -1. A prime is -1 comma 3. We're just switching the coordinates. Notice that -1 comma 3 is 2 diagonals away from the green line in the opposite direction from point A. Point A is 2 diagonals to the right of the green line or below. B was at 3, 2. B prime is going to be at 2, 3. And again, you can see that they're the same distance away from the green line. Connect the segment, and now you have reflection. If you were to fold this graph across the green line, the two segments would overlap themselves perfectly. Finally, example 3c, the vertices of JKL are as shown, and we're going to graph its image after reflection in the line y equals -x. So let's graph the triangle. There's 1, 3, 4, 4, and 3, 1. And we're going to graph the line y equals -x, which is down there. So we're going to apply the coordinate rule for reflecting in y equals -x. That's A comma B becomes -B comma -A. In other words, you switch the X and Y coordinate and you change both of their signs. So in this case, everything was positive. All the coordinates now will be negative. So let's start with point J. J was 1 comma 3. J prime is flipping the coordinates and then making them both negative. -3 comma -1. And you can see J prime is 2 diagonals away from the green line, just like point G, but in opposite directions. We'll do the same with K. K prime is -4, -4. Notice that the X and Y coordinates are the same, so you just switch them and then make them both negative. L was at 3, 1. L prime is at -1, -3. You connect those points and notice, again, this triangle is reflected across the green line. If you were to fold this across the green line, the blue and the red triangle overlap themselves perfectly. So that's the end of part 1 of 11.2. If you have questions, feel free to send me an email or join one of the office hours.